Hey everyone, welcome back. So in this mini lesson, we're going to be talking about the definition of potential energy. And a lot of people make the mistake of thinking about potential energy as like a stored energy. For example, I ate breakfast this morning and I had my bowl of Wheaties and milk and coffee and orange juice and muffins and bananas and, well, okay, maybe I had just the Wheaties. But anyways, people think about all of this stored chemical energy when they think of potential energy. Or sometimes people will think of batteries and be like, oh, there's energy stored in the battery. Well, that's not really what potential energy is. What potential energy really is two things. You could think of potential energy as energy due to position, or the other way you could think about it is not stored energy, but stored work. In other words, if you've done work to an object, like lifting a book, you've put work into it and you've changed its potential energy. Later on, when that book falls back down, then that energy gets converted back into kinetic. So potential energy um, is really more about position and where things are. And it's important to try to understand this now when we talk about things like gravitational potential energy, so the potential energy due to gravity, or if we talk about potential energy due to a spring. It's important to understand this concept now because later on we'll start talking about electrical potential energy and things of that sort, which are a much more abstract concept, and you really have to fall back on this idea that it's energy due to position. Okay, well, because it's energy due to position, usually potential energy requires a 0 point. And when we talk about potential energy due to gravity, usually a convenient 0 point is the Earth's surface. And so the equation that we're going to use for the potential energy of gravity, well, if you think about this, it kind of makes sense. It involves g 9.8 meters per second squared. It's going to involve the height of the object above the 0 point, and it also depends on the mass of the object. So the more mass you have, the more potential energy. So this is going to be our equation for the potential energy due to gravity. Now, if you want, you can be fancy and you can say that really potential energy due to gravity is a change. So it's final minus initial, like when we always write change. And you could write that as mg times h final minus mg times h initial. All right, but if we're clever, we can say that the initial height is 0, and so when an object's potential energy changes, it's simply equal to mass times gravity times its new or final height. So that's a little bit of a trick. One other thing you may discuss is potential energy which is stored in a spring. And this is related to the lecture on work when we talked about the fact that the area under a force versus distance graph, so that area is the work. Well, when you put work into something, you change its potential energy. And for a spring, because a spring usually goes by the spring force, which is equal to the spring constant times the displacement, and because we have a triangle here, hopefully you'll believe me. I could also write x instead of the displacement, but the potential energy of a spring is 1/2 k times this displacement x squared. And this is something that you can look at in a little bit more detail in your textbook. So there's other types of potential energy. You can have potential energy due to electricity or electric forces. You can have potential energy due to magnetism. And as we'll find out later, there's actually a different way to write potential energy due to gravity, but this is pretty good for now.